Hello children. Now in today's video we are going to see the part 4 of our ray optics lesson, in which we have to say about refraction in our daily life, and we are going to add some sign conventions with what we have learned already, and we have to learn about prism, and we are going to see about what is dispersion, and we have to recall some concepts in detail about refraction in different mediums. Okay, what are the less concepts what we have learned in the previous classes? Previous class we have learned about sign conventions, what we have to follow in mirrors, and we have studied about refraction, laws of refraction, and the refractive index, and related concepts and formulas about it we learned in the previous class. Yes, no children? I had seen your classworks, and some of you have not yet finished your classworks. I hope in the next class when we meet in the school, I will see you with your completed classworks. Yes? Okay, now let us move into our lesson. Right? So first I will explain this concept. Right? So that when we explain this, with this help, I can go with the other concepts. Right? Now, when refraction, I told you in the previous class, what is refraction? It is the bending of light when it travels from one medium to another. Right? So now I will show you a glass slab. Okay. Now, so this is your glass slab. Right? So now imagine that this line I have drawn also, right? So that is your medium. Change of medium. Now when I keep here like this, right? Now one light will enter here. Now it enters from air medium to glass medium, right? So now medium gets changed now. So what will happen? When there is a medium change, light will take a bend. So that process is called as what? Refraction, right? So what is refraction? So now hereafter we have to think that when I explain here, this line refers to that glass slab. Example, you can take any medium as an example. Even you can take as water surface also. Now here you imagine like glass slab, right? So when there is a change in the medium, right, on a travel of light ray, the light ray instead of traveling in a straight line, it will take a bend. So that bending process is called as refraction. The bending of light ray when it travels from one medium to another medium is called as refraction. Okay, fine. Okay. Right now, there are two types of medium here. One is rarer medium and another one is denser medium. What is rarer medium? A medium, I already have explained you what is the medium, right? It is the place where light ray will travel, right? Now, when the particles of the medium are very far, like the space, air medium, right? Here air can move anywhere in the space, right? In the rarer medium, light can travel in any direction, right? In any fast manner it can travel. But when it enters into the glass medium, what will happen? In the glass medium, the particles are so closer to each other, right? So what will happen? The particles in the medium, that is inside the glass medium, what it will do? The particles will attract the light ray, will pull the light ray towards it. Okay, so what I am trying to say here, when light ray travels from rarer medium to denser medium, rarer medium is one in which the particles are apart, right? And denser medium is one in which the particles are so close to each other, right? Now, when it travels like that, the light ray will bend towards the normal. Bend towards the normal. So this is rarer medium, this is denser medium. This light ray is called as incident ray, and this light ray is called as refracted ray. Right? Not reflected as we saw in the part 1 video or part 2 video. Here it is refracted because the process here is refraction. Right? Now, what is the concept here? When light ray travels from rarer medium to denser medium, the refracted ray will bend towards the normal. This line is called as normal, no? So, the light ray will bend towards the normal. Right. when the light ray travels from denser medium to rarer medium. If an example is like this, what example you can say? If the light ray comes out from the glass medium to the air medium, okay, it comes out. It is just like water coming through an hose pipe flushing out, right? So if it is going through a pipe, right, so it travels in a very denser area. When it gushes out, it can splash out. Its area of travel is wide. So it comes from a denser medium to rarer medium. If that is the case, in that examples, incident ray and this is the normal, what will happen to the refracted ray? The refracted ray will bend away from the normal. Away from the normal means why? It is moving into the refracted medium. It will gush out. It will spread out in with the greater speed. Okay. So two concepts we have learned here. When light travels from rarer to denser medium, it will bend towards the normal. If it travels from denser medium to rarer medium, it will bend away from the normal. Clear, student? Very, very important one. Now, keeping this in your mind, come here. Right? Now, we have not refraction now, children. There are some applications of refraction in our daily life. Where and what we can use it. So, that is what we can see here. Right? Now, we can see the stars twinkling on the sky in the night time. Yes? So, how do we explain it? How we can see that stars are twinkling? Right? For that, this example is given. Right? Now, if this is considered to be the Earth's surface where we are living. Right? So, if this is the sky where the stars are glittering. Right? Now, the space in between us will contain many layers. Right? Atmospheric layers. Right. Now, near our Earth's surface only, density of gases. Here only we have air to breathe. Right. All our gases are present near the Earth's surface only. Right. So, near the Earth's surface only, gases will be there. So, density will be more. Right. When we move up, when the height increases, H refers to height. When height increases, what will happen to the density? Nothing will be present at the higher areas. No, as we go higher and higher, air won't be there. So, thickness of the atmosphere will reduce. Density of the air will reduce. Because nothing, as we go up, we cannot get air, no. So, density will be reduced. So, as height increases, density will reduce. So, what will happen? Density here gets reduced now, children. So, here density reduced means just now I explained. Thicker medium, a denser medium will not have that much density. Sorry, denser medium only will have higher density and rarer medium can spread down. Right? That's what I said here. Now, as we move higher, what will happen? The gases won't be there. So, density will be less. Right. Now it comes over down here. It comes to denser and denser medium. Near the Earth only it is denser. Right. So it is like if the star is coming from here. If the star is here, the light ray coming here. Now the density will increase. Now again it will have one layer. Again density will increase. Like this, the rays from the stars will travel through different layers of different density, right? So it will take a bend, right? So when it reaches us, we people on the sky, for us, the light ray will look like it is here. Actual position of the star will be here only. But as the light ray takes a bend, for us, it will apparently in a false manner, it will look like it is somewhere else from the original position. What is the factor behind it? It is due to atmospheric refraction. Apparently means what? What is that? In a false way, false. It is not actually situated over there. It is a real position is here only. But due to the refraction of light, what will happen to the star position? So due to multiple reflections at different layers, for us the stars appears to be glittering. Clear, children? Right. So now the light travels from rarer medium to denser medium because of less density. As we come down, density increases. As we go up, density decreases. Don't get confused here. Okay. So right. So the light travels from rarer to denser medium. So the light will take a bend towards the normal as we saw here. Okay, so the same process happens in the next process also. It is early sunrise and delayed sunset. Say the word early sunrise and delayed sunset. Okay. Now if this is going to be the Earth atmosphere, so Earth's surface, right? Now in the early morning, if the sun is rising, okay, so here the sun is little far away from us during sunrise or sunset. The light ray has to travel a long distance. Same way as it happens, the light ray takes a bend through different layers. Here also the sun's light will take a different bending, refraction will happen. So when it reaches us, what will happen, oh children? It will also travel from rarer medium to denser medium. So it will take refraction, so many refractions. So for us, sun appears a few minutes earlier itself due to that refraction process. Is that clear, children? What is the process here? Actually, the sun will be here, right? Due to the multiple refraction, we will be able to see the sun a little earlier itself. So that's why we say the word early sunrise. Same happens in the evening also when the sun sets. Okay, so it will take a delayed sunset. Okay, actually the sun would have got set at 6 o'clock means actually. For us, sun will appear like it is getting sunset at after 6. Right? So that is due to a process called atmospheric refraction. Say the word atmospheric refraction. So what are the two applications? One is twinkling of stars, another one is early sunrise and delayed sunset. Clear, children? Very important. In detail again you will learn about this in your higher classes. Now as of now know these concepts. Okay. Right. Now this I had explained. Now another application you have, objects in water appears to be bigger due to refraction. Right. When you immerse a ball in a big pool of water, in a big vessel of water, right? Now when you press the ball, what will happen? The ball will appear bigger. Would have experienced this, right? That is due to refraction of light because the medium changes over there. No. What is the medium change? Light travels from air medium to water medium. Clear, children? This is the third one. What is the fourth one? Pond appears shallow. When you see a pond means what? Follow. We say no in covered. Right. Next one, a pool of water, a stagnant water. When we see through it, though it may be little deeper, for us it will look like a shallow one, not that much deeper. Why it is like that? That is also due to a process called refraction. Okay. Now, when there is a coin inside a vessel of water, for us the coin appears to be, when you see from outside, the coin appears to be little raised from its position. It will be like little it is there on the top of that base. So that process is also due to refraction, right? And now this one, the third one, visual distortion. Have you ever seen in TVs and also even in your real time, some of you will would have got this experience on catching fish in the pond or some stagnant waters. Some people will have sharp objects in their hand. Have you ever seen? They'll just see the water, flowing, and when there is fish going, fish swimming over there, they just pierce with their sharp end to catch their fish. Have you ever watched this in any videos? Right? In that, inside the water only we will be seeing, no children. So we cannot clearly see that image on that moving of water. Right? So that visual distortion, disclarity in the seeing. So that visual distortion will happen due to a process called refraction. Okay, so these two are due to atmospheric refraction. These three are normally it is due to refraction. Okay, right. Now in your previous class, I have told you about that. I will show you what are concave mirrors and what are convex mirrors. Now I am going to show you, children. Now I have a mirror in my hand. I have another mirror. Right? I am coming a little closer to you. Right? You can get that glittering on your face. Right? Now you see this mirror's back side. One side is polished and one side is made to be reflecting. Right? So in this, one type of mirror is here and another type of mirror here. And this type of mirror is called as concave mirror. Right? And this is called convex mirror. Right? Now, as I used to this, I can easily touch and experience. Right? So when you come to the class, I will show you this and make you to touch and feel. Okay? Right? So one is concave mirror and another one is convex mirror. Here one side is polished and one side is reflecting. So this we call as mirrors. Now I will show you one another thing. See, both no polished surfaces here. Both are reflecting surfaces only. Here we call it to be refracting surfaces. So if no polished surfaces are there, we call it to be lens. Okay. So this is concave lens and this is convex lens. I will show you this in the class. You please ask me, ma'am, you told that you will you show that the lenses and mirrors. I will bring it and show to you. Okay. So concave lens, convex lens. Right. Now, when these lenses are going to be used, already in the previous class we have learned Cartesian sign conventions. Do you remember, children? Right and upwards is positive, left and downwards is negative. Like that, when it comes to refracting surfaces, lenses, right? We have two more conventions, adjustments, rules. What are they? For converging lens is the other name for convex lens. Power of the convex lens is to be taken as positive. Power of the diverging lens is concave lens. So concave lens power is taken to be negative. Right? So these two sign conventions we need to add with the previous conventions what we have learned. Okay. So nearly 9 points we have learned before. Along with this, we have to learn this also. Okay. Now we are moving to prism. What is a prism? Now I am showing you a triangular surface. Right? Now can you see this, children? Right? Now this object, a solid glass object, is called as prism. A solid glass with 3 rectangular faces. See here. This is one rectangle face and this is one rectangle face and bottommost one. So that will have another rectangular faces. 3 rectangular faces and 2 triangular faces. 2 triangular faces. See, can you see, children? So this is your triangular face. And right. So now one rectangle, another rectangle. Now here. Right. And see here at the sides you have 2 triangular faces. Right. So this is a solid glass with a structure like this. That structure we call to be prism. Say the word prism. P-R-I-S-M. Okay. Now this prism, through that prism what will happen? When I send a white light, a normal white light, not the tube light, children, a sunlight. a sunlight which contains all the 7 colors inside it. Right? Rainbow, have you seen? Right. Now the sunlight, when we pass through the prism, what will happen now, children? 7 colors will come out of it. When you come to the class, I will show you that activity. Okay. Now, when 7 colors come out of this prism, when we send sunlight to it, that process is called as dispersion. Say the word, children. Dispersion. dispersion. What is dispersion? It is splitting of white light into 7 colors. Right? White light only will get split up into 7 colors. Right? So that process is called as dispersion. And that 7 colors we get to know, children, as per single pattern. That 7 colors we call to be spectrum. spectrum. Okay, children. So dispersion is the process, and what we get is called as spectrum. Right? A rainbow is an example for natural spectrum. Now, the last pattern we are going to see. So this prism I am showing you now, children. Right? So that I have to explain you some parts. So I have drawn that here in a 2-dimensional way. Right? So this shows the structure of the prism. When light is sent through it, that light ray is called as incident ray. What is that? Incident ray. Now this is the glass medium now, children. So there will be a change of medium. Air medium to glass medium. Rarer medium to denser medium. So what will happen here when there is a change of medium? Refraction process will happen. So the light ray will take a bend. Instead of traveling straightly, it will take a bend. Right? So when it takes a bend, what will happen? It will take a bend and travel like this. Now again there is a medium change. It travels from glass medium to air medium, denser medium to rarer medium. Now again there will be a change in medium, so it comes away. Here I told you, do you remember? Rarer to denser means towards the normal. Rarer to denser means light ray will bend towards the normal. This dotted line, children, that is called normal. What is normal? Here you see, normal will make an angle of 90 degree to the surface. Like that, this normal line will make an angle of 90 degree. With what? With the surface. Surface means what? The prism's surface. Right? Right. Now here it is coming out from denser to rarer medium. So it will make bend away from the normal. It will come away. So this is your normal. Right? Now what are the 3 rays I have taught you here? What is this ray? Incident ray. This is your refracted ray. This is your emergent ray. Right? Okay. Now we are going to see some angles. The angle between the incident ray and the normal is called angle of incidence. So I have written the angle of incidence. Right? Now this angle, the angle between, there are 2 angles over here, no? The angle between the refracted ray and the normal, there are 2 refracted angles over here. They are called as angle of refraction. Okay? So there will be 2 angles of R1 here, R2 here. This diagram is there in your book. Quite follow it, right? Right. Next one. This ray is called as emergent ray, and the ray angle between this emergent ray and the normal is called as angle of emergence. So it is denoted by the letter E. Right? So what are the 3 angles we have learned now? Angle of incidence, angle of refraction, and angle of emergence. Right. Now one another angle we have. Now I told you here this incident ray will take a bend. If it is not going to take a bend, always we used to produce a line, children, like here. See here, it is taking a bend. but when we produce it, it is goes straightly. Right? So here also you see, it will take a bend here, but when we produce it, it will be going straightly. No, like that. Here, if we produce this incident ray and the emergent ray, it will meet at one particular point with one angle. That angle is called as angle of deviation. Say the word angle of deviation. So we have three rays: incident ray, refracted ray, emergent ray. Four angles: angle of incidence, angle of refraction, angle of emergence. See the words, children. Ray means incident. Angle means incidence. So these word formation must be very clear. Don't make as silly mistakes what you usually make in the classroom notebook, right? So the word formation here, incident should not come. Here incident should not come. Okay? So don't change that word formations. Right? So angle of deviation. So dispersion spectrum I have explained to you. Now in the previous class I told you that some apparatus I will show you. This is your screen, right? Now you can show this. This is your magnifying glass, and Tamil we say this to be Bhuda Kannadi. Have you ever seen this, children? People who see our fingerprints, right? So they have this. Now I have my fingerprints here, right? Now you can quite see in a very bigger way, right? Right. Now I will show you in a screen. You can see the images, right? See this, children? So I am just focusing the window here. If you are able to see it, can you see the window formation there? So the window can be seen very clearly here. Can you see the, children? See how the window is seen here, but in an inverted way, right? See, when you go up closer, it will become blurred. Right now, I am bringing it closer to you. So now you can see the window in a very clear way. Can you see, children? Very nice now, right? Okay. Now this I will show you in the class also. Okay. Okay. Now finish up the classwork. Come prepared for the test. Okay. As usual. Thank you, children.